I was sent a couple of these 10 watt LED floodlights that had failed, and they're super low profile. They've got, instead of the usual sort of 10 watt LED, have I got a 10 watt LED? Yep. Instead of one of these sort of 10 watt LEDs inside it, it's got 20 half watt standard LED packages, the surface mount type. And it really is, it's very, very low profile. And to save time opening it up, I've had to already, I've been playing about with one. Here's the circuit board that's inside. And the power comes in, and it's an aluminium core PCB. Well, I say it's an aluminium core, it's an aluminium back PCB. Basically a piece of aluminum with a thin layer of the fiberglass laminate with the circuit board on it. And that actually made soldering these new tails on very difficult. It really sucks the heat away very quickly. But here's the gist of it. The mains comes in, it goes through a 3 ohm resistor which is acting at a fuse. There's a metal oxide varistor to clip any transients, goes through a rectifier with a little there's a little shunt resistor across it. I think it's just for to reduce the effect of stray capacitance, the circuit board in operation. And then there were 2 little chips which are in parallel. Now these chips are CYT 3000A chips. And in this application, they're actually bridged in parallel. They're not running half the LEDs each. They are actually physically linked with all the outputs in parallel to handle a higher current. I'm not sure how that goes actually. So it certainly isn't mentioned anywhere in the data sheet, but this is the system whereby it has the LEDs on a string, and it's got a sense resistor. Hold on, I've got a bigger version here. Here is the double version, according to them, but it is divided into 2 sets of LEDs. They've not done that with this one. It is just the chips are virtually, and they might as well have just sat them on top of each other, more or less. But it's got the LEDs in groups. Initially a very large group of LEDs, and then smaller groups. And as the main sine wave, there's no smoothing or anything like that. As the main sine wave rides up, it starts lighting these ones, and as soon as the current through them exceeds a certain voltage threshold across this resistor, it disconnects that and bridges in the next set. And again, once it reaches the next threshold, it does the next set, and it just basically stacks the LEDs on top of each other to create the higher voltage, so it's lit for a modest portion of the sine wave. Now, I was hoping to fix one of these and then do a wee test. I was going to do an electron update test. Now, electron update does lots of like higher profile LED lamp reviews, and what he does to actually test them is he uses a little solar cell connected to an oscilloscope, and it actually generates the voltage for the oscilloscope, gives good isolation. You just place it across in front of the light and it will show you the waveform, and I was toying with doing that. But I noticed, for a start, well, I'll show you this, see if you guys, I'm not sure if you're going to be able to see, can you see what's faulty with this one? Not sure if you can see that or not. But 2 of the LEDs in it have the black spot of death. You can actually see the black dot inside. And that was the case with this one as well. One of the LEDs had failed. And these might look like single package LEDs, but they actually contain 3 chips each, so it actually adds up to a really large number of LEDs. Let's see, it was effectively, where's my other doodle? Oh, there we go. This is how they're wired. So, if I put this up like this, this is roughly how it's laid out on the circuit board. The mains come in, going to the rectifier, and then the positive end goes straight to this section of LEDs. And these LEDs are wired. The first section, the first 3 in each row are actually zigzagging backwards and forwards. They make up the bulk, and then there's a tap-off point here, and then that's one pair, and then there's another pair, then there's another pair, and they go to the pins. And that's the way these chips always seem to work. It seems to be a large number initially to make up the bulk of the LEDs, and then it's just smaller sections on top. And the 2 chips, well, there was one there, I've removed it. I took a lucky gamble, and well, it wasn't actually a lucky gamble, it was an unlucky gamble, but you know, these things happen. And they're linked with these sort of printed circuit board, these sort of just wire links, they're surface mount links to common all the pins together. And initially I thought, well, there's one LED failed, it's got the current limiting, it's got the detection, I should be able to bridge that LED out and it should work again. And I did, and powered it up, and it lit very briefly, and then this one got the black spot of death. I thought, oh, there's something more here. So I thought, let's try shorting that one out, and I bet another one does it. And yep, it lit briefly, and then this one died a death, and then they just glowed dimly because it had basically opened the circuit, and there was just a bit of leakage going through. So then I started probing about here and found that one of the pins on the output on one of the chips had directly bridged to negative. It wasn't actually switching at all, it was just a dead short, as often happens. That's how things fail, the sort of high current switching components, they often just fail dead short circuit. So I'm guessing that's the case, that it wasn't switching. So I thought, well, I'll try and desolder one. And again, heat gun, soldering iron, desoldering braid, screwdriver levering. It was so hard to get that chip off. I ended up just cutting the leads on it and then prising it off, and I think I took the tracks off with it. But very difficult because of this aluminum core, this aluminium backplate. However, the one I took off was probably the good one because the fault's still there, so that's a bit disappointing. However, it's interesting to see how these are made. I will say they were earthed, which is good. There was a screw going onto the clamping this down, just one at each corner I believe. It wasn't the full complement of 4, and it was pinching this earth crimp, so these ones were earthed, and yeah, it had loads and loads of the white goop underneath. I'm just wondering now, is this one going to have the same fault? I think we should open this up and check that out right now. It's a nice enough smart little light, but you know what, I can't help feeling that given that they've effectively got 1, 2, 3, 4 by 5, they've got 20 LEDs in there, each with 3 chips, that's 60 LEDs times the 3 volts forward, that's about 180 volts. For a 240 volt fixture, they could have actually used a capacitive dropper in this, and it would have, you know, there was room enough for the capacitors at the side and the other components, it would probably have been more reliable. Not sure why they've gone the route of using those little chips. But let's pop the lid off this one. I'm trying to think if I could repurpose these cases in some way. They're quite smart. I think it would require redesigning a circuit board. Even if I could have changed the chips, or even just cut the faulty one out so that it was running at half power effectively, it wouldn't necessarily let me get the whole thing up and running because these 3 chip LEDs are kind of specialised. So 2 diagonal screws holding the reflector on, as is so often the case. It was also quite messy, as you'll see shortly. Getting the, oh right, okay. This is another thing, it's got a silicon grommet in the reflector that kind of stays put on the circuit board. Oh, there we go. To avoid shorting it out, the metal tray shorting it out. So once again, the 2 diagonal screws, there's the earth over there. And this is swimming. They've really dumped a load of goo over the top of it to try and sort of seal it, and I'm seeing that that's kind of displaced the rubber gasket has displaced that down, so it was probably still wet when they put it in. So let's see if these chips are the same situation, because I do see that it's really blown up quite a few of the LEDs. I would guess it might be the same outputs that have failed. Am I going to get connected through onto through all the goo? See, that's what I was guessing before, just pretty much a near dead short circuit in those pins, but not on the other output pins, just that one, and of course it's going to be the same down there. So now I have to work out which of these chips is the culprit, which one is 0.267, it's not, it's going to be so close that, you know, I'm not going to be able to tell which of these chips it is. Yeah, it's tricky, I'm not sure, because technically speaking I kind of want to chop one of these chips out and see. So last time I chopped out this one, I could try chopping out this one right now and just see. I mean, maybe that's how the chip reads when it's not powered, but having said that, the fault really was so vivid, so I'm going to chop this chip out right now. This one is not oozing with the... That's odd. The other one was absolutely plastered with heatsink compound. I'm not seeing any under this one at all. Does that not have any? It might just have a wee thin spread, but that one was just like to the point of ridiculousness. It really had tons of the heatsink compound under it. Oh, it's got a modest amount. Yeah, that's like that, but double. So, yeah, I'm not going to leave that out. That's pretty messy. I'm going to stick that screw back in again just to keep that in there. Because it really is messy. I'll just pop one in. So, I'm going to chop out, this time I'm going to chop out that chip. And there's no saying which of these chips has failed, if indeed they have failed. These are covered in that silicon goop. Oh, I'm thinking lifting tracks. I'm most certainly lifting tracks. Well, let's just erase that chip completely then. I'll just snap it off. Now, has that cleared it? Or is the fault still going to be there? Oh, that's interesting. Right. So this might, if I bridge those LEDs out, this may well work. Right, I'll be back in a moment. So a few modifications later, I linked out the two bad LEDs. Unfortunately, the last one is just one of a pair. I'm not sure how that's going to go. It might just take out the chip again. Oop, I'll just remove a little bit of wire I've left in there. Don't want floaty bits of wire floating about. And so I bridged out the two LEDs and then tested the LEDs, and I found the first one was lighting very dimly. It was just passing very little current, so it was obviously on its way out as well. So yes, lots of heavily overcurrented LEDs. But anyway, I have bridged out those and I've not tried it yet. So I'm about to apply 240 volts to it and see what happens. And I thought, you know, I might as well turn the camera back on and share the moment with you. 3, 2, 1. That's working. Okay, right. Let's do some further experimentation, shall we? So a little bit of oscilloscoping later, and it is actually riding both sides of the half wave. Now I'm not sure why the silicon photocell didn't drop right down to zero. I'm guessing it was either phosphor persistence in the LEDs, or maybe there's an element of persistence in this. I'm not 100% sure, but I would have thought it would have dropped right down to zero, but instead it sort of tailed out, and I'm guessing it is. I'm pretty sure that would be the sort of cut-off point the LEDs cut off, if you can see that, because it is very black, and then it kicks up again. But if I bring in a bigger version of this, I've zoomed in on one of the waveforms, you can see a slight distortion at the top. I'm not 100% sure if that's the extra sections of LEDs at the end switching in, or if it's the current regulation of the chip, because the chip is obviously acting as a current regulator because it is holding the LEDs on all the way across the top. And if I bring in I sort of scaled it up manually, the LEDs will turn on, the first set of LEDs will turn on about 86 volts. That's assuming the turn-on voltage about 2.4 volts per chip, which I measured it, and it was about that it was just starting to conduct and glow at that level. And there's 3 chips in each LED. In this case, I've got the first section, now I've shorted to them, just has 12. Just to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times the 3 chips is 36 chips times that 2.4 volts comes to about 86 volts that it would start conducting. And then as it went up and the current increased through the LEDs, it would then switch in the extra sections of LEDs. But that still means that it's well short of the peak mains voltage, and it is dissipating that as heat across the chip. And that shows, if you look at this thermal imaging camera image, because the chip was up to about 96.9 degrees centigrade very quickly, and keep in mind this is well heat sinked, it's on that aluminium, it was really hard to desolder, it was really sinking heat away, and then it's got this aluminium case behind it. And it's no great deal in a sense, because the specification sheet for it says it can go up to its normal operating temperature, it can go up to 120 degrees centigrade in normal operation. The LEDs, on the other hand, well, they're actually only running at half current here, but they clocked up in about 43.1 degrees centigrade. Having said that, with the extra chip, because both the chips were in parallel, it would double the current through the LEDs. So I kind of I wonder what made these fail. Both of them fail in that particular style, with the chip actually blowing on. It seems to be the channel, the pin, that ends up taking all the current. I'm just going to check that right now. Where's my meter? That one's shorted, so that one, yeah, it's the one that ends up taking all the current of all the LEDs in series. It's that pin that failed on both those circuits, and only one chip in each failed. Unfortunately, in that one I whipped. Unfortunately, in this one I whipped out the good chip accidentally. You couldn't tell. But obviously when one fails and it shorts it out, then it takes the pressure off the other one, because, well, it's going to start blowing the LEDs like fuses. Another one, it just sees 0 volts cross it once that's shorted out. So interesting lights, but I still think, in an application like this, one of the main features of these is they claim it's near unity power factor. It's like the current follows the voltage very accurately. With the capacitive dropper, there's a phase shift, but I don't think it would really be such a major issue with that. So in a sense, for such a low power light, I would have thought that, you know, it would have made sense to use a capacitive dropper in these. But having said that, they're quite interesting lights. So just for the hell of it, I decided to make a modification to this one. I decided to fit a capacitive dropper with smoothing capacitor in, and it works fine, as I'll show you. It's got 3 LEDs out, but that's okay. That's the 3 LEDs that were blowing during the experiments, when they were just failing. You know, every time I fixed one, another one failed because the chip was faulty. So in this case, I've got a 680 nanofarad capacitor, a 4.7 microfarad smoothing capacitor, a 100 ohm resistor, just actually as a bridge to bridge the circuitry over to there to the LEDs, and it runs about 4.5 watts, roughly the same current as just one of these chips was running these LEDs. So I think you'd need probably a 1.5 microfarad capacitor to get the same intensity, but that would bring it pretty much up to 10 watt, pretty much like the high capacitors they tend to use in the largish ceiling globe lamps, the ones that have got shitloads of LEDs in the capacitive dropper. So yeah, worth mentioning, the reason there are only 2 screws holding these in is because someone at the factory has made a terrible mistake, and the fixings do not correlate to the holes. I wonder, they must have been absolutely mortified when they discovered that. I wonder if it's a change in the aluminium housing, or if they just got the measurements wrong and they just based a printed circuit board on what they believed the measurements for this was, and it was wrong or something like that. But yeah, so I'm thinking to get these in, the components would have to be sort of folded up against the side of the case to allow the reflector, but they would all fit, you know, just tucked up against the side. But yeah, that's yeah, the capacitive dropper would have worked just fine. Yep, good result and quite fun as well. Yeah.